Right, your first question that I gave you was to define the term algorithm, all right? You will get 1 mark for acknowledging that it is a sequence of steps or instructions, all right? So you get 1 mark for saying that it's a sequence of steps or instructions, all right? That's only one of the marks. The next follow-up mark is to acknowledge that it is for solving a task or problem, all right? So that's mark 1. Mark 2 is to complete a task or solve a problem, all right? So you've got to get in the word steps / instructions and to complete a task or solve a problem, all right? That's how you get the 2 marks on that. Now, let's have a look at this here. This introduction is very useful because it reminds you what modulus means, all right? So it says it uses modulus, which is represented in pseudocode, and the lines, these numbers are not part of the program. They're just the line numbers, okay? So it says the modulus operator is used to calculate the remainder. So if you had 14 divided by 3, the remainder would be 2. 24 divided by 5, the remainder would be 4. All right? So that's what that's getting at, and it's giving you an example here. But what it does here is it says, shade 1 lozenge that shows the line number where selection is first used. All right? How do we spot selection? 2 letters, if. Well done, all right? That's why I put a ring around that there. So that is your selection there, and also the structure. You can see the indent, all right? So it should have been line number 2. All right? That is the line it was on. That is where we found if. Any questions on that? Hopefully not. Right. Then we move on to the next set of questions. It says, show 1 lozenge that shows the output from the algorithm. So you just look here, where can I see that shows the output when the input is 4? You've got to read the full question, because if you don't read it properly, you're going to just go, oh, there's an output on line 5 and select that. That's not what it's asking. Look, if I is equal to 4, all right, what's 4 divided by 2?
2.
So what's the mod going to be? 0. So that's saying if 4 mod 2 equals 0, then output was I times I. What's 4 times 4?
16.
That's why your answer was 16. It's about following what's happening with the structure of the code. Alright? Because the value of I was 4 in this case, 4 mod 2, there was no remainder, so it did 4 times 4, which gave you 16. You've just got to follow the algorithm. They're not too difficult if you take your time. So that's why we got 16 there. It says, shade 1 lozenge, where the assignment is first used in the algorithm. How do we spot assignment? What symbol? Yes, look, you can see a symbol, the arrow is used there. So on line 1, the first time it was used was on line 1, therefore my answer to C was line 1A. Alright? Now show me where a relational operator is. Relational operators are the operators that are used for your comparisons, like your greater than, your equal to, your is it equal to. It's checking the relationship between 2 values. That's the best way to remember it. So, where's the relational operator in here? Line 2. There's your equals. Should have had line 2. Alright? Right. I'm going to give you the reason why the answer was D here. Alright? This algorithm does not use a Boolean operator. Boolean operators are true or false. Okay, I can't see that anywhere. Alright. If you don't see the word const in pseudocode, it's not using a constant. Therefore, process of elimination, they're not right. Iteration, what do I use to, how can I spot iteration? For, while, or repeat until. Can I see any of that anywhere? Right. Process of elimination, therefore this must be right. But not only that, multiplication is used there. I times I. Alright? Right. Moving on. This question here was quite easy to eliminate two of your answers from the get-go. Alright? The reason why it says, it's giving you a program here, and it says, here's the line numbers. Now the program figure 2 needs to be changed so it repeats 5 times using a definite count-controlled iteration. So count-controlled, how do we spot it? What word? Yes. Count or definite is always a for loop. Alright, conditional is while or yeah. Okay, obviously this is actual Python code here, so the repeat doesn't apply. Okay, so because I know it's not a while because it's asking for a count control, I've eliminated these two while loops. I know that it's not looking for that. Now it says it repeats 5 times. Alright, remember you count the process of going from, let me just write this down, 0, 1, 2, 3, 4, 5. The reason why it was A is because to get from 0 to 1, that's 1 repetition. 1 to 2, that's 2. 1 to 2 to 3, 3 to 4, 4 to 5. That's 5 repeats. Okay? So the reason why 0 to 5 in this case was only 5 is because it's inclusive. Okay, so you go from 0 to 1, 1 to 2, 2 to 3. That's the best way to help you remember that. If I'd have put 6 in there, it would have gone from 0 to 1 to 2 to 3 to 4 to 5 to 6, which would have been the 6th repetition, which wouldn't have been right. That's the logic there. Okay? Am I making sense? Hope so. Right. Right. We're looking at question 3. Keeping an eye on time. I don't want to run out of time. Right. So, step 1. What this is asking you here is to do a linear search, and it's asking you to go from value 8 to find value 8. What you've got to do is you've got to, whenever you are doing searches, you've got to acknowledge that you're going from like 0, and comparing against the number. So I'm going to start at positions 0 and compare 8 with 4. You have to say what you've compared it with to get the mark. I'm looking for the value 8, so I'm going to check and compare the number 8 with 4. Is it that? No, it's not. Step 2, I'm going to compare 8 with 7. Is it that? No, it's not. Final mark is compare 8 with 8. It is now true, therefore it is found, and you can stop. That's where so you've got to say it's been found, it's got to stop. Alright? So talk about your comparisons. Okay. Next question. Programmer wants to implement a search algorithm to be used with small arrays. And it's pretty much a similar question. Alright. The figure below shows an example of an array. What you got to do is talk. Alright. There are 5 marks available here. I'm just going to show you on the mark scheme so you don't have to read my handwriting there. This is question 3. No, question 4. 1 mark for saying the search begins with the first element, or 4. Alright? So you're saying you go to 4, compare it. Second mark, the element is compared to the value being searched for. So there's 2 marks available there. You're saying what you're comparing. So the 4, you're comparing with the 15 that they've given you. So there's 2 marks available there. Then you've got to acknowledge with this type of search, it iterates. It goes through each item in the list. There's a mark for just acknowledging that you go through each item, alright? It's about you explaining it and breaking it down. Then your last mark is saying if it does not exist, then if it does not match the value being searched for, then the iteration continues. The search returns true if it's found, and so on. Alright? Anyone have any queries about what they've written, about whether it would work or not? No? I'll leave that up there for a second.
So,
Yes.
instead of saying first element, you can say index 0.
You'd need to say the first item in the array, don't just say the index. Or the index of the array.
Yeah.
Starting at, yeah, so acknowledge that you've used that 0 as the index of the array. Get the word array in there somewhere to show that you fully get that, alright? Any questions? I'll leave that up there a bit more so you can write that down, and then we'll move on to the next question. Right, moving on. 4. What's question 5? Is question 5 the one that I gave you as an insert? Okay, that's question 6.
There's 4 BNs.
Yeah, there we go. That's what I was looking for, sorry. This one here. Right. What property of an example array in the figure means that the programmer could use a binary search? Have a look at the array. It was in order. It was sorted. If data is sorted, you can do a binary search in it because you can split it in half and see if it's in the top half, if it's in the bottom half or the top half, and then split that again. Remember how a binary search works? You divide it by 2, check whether it's in the top half or the bottom half. It's called divide and conquer. Then, yes?
Could you say there's an odd amount of numbers?
No, you can't say that. You have to say that it's in order. That's the golden rule of a binary search. All the items in the list have to be in an order. Okay? The next question says the programmer knows that a binary search is more efficient than a linear search. Explain why the efficiency of these 2 algorithms is not an important factor. Well, when you've got small lists, it doesn't matter. It's only when your numbers are huge. Okay? Because if I'm doing a linear search on 1,000,000 items, it could be the 1,000,000th item in the list. But if I'm doing a linear search, it could be the 1,000,000th item in that list. With a binary, I'm halving it each time, so it's going to be a lot quicker. Yes?
What if the number you want is the first number in the...
This is why it doesn't matter, because if it's small lists, it doesn't matter. But even so, you've just got to acknowledge the size of the list. And talk about, if you've got 2 lists that are very small, the runtime will be similar. That's why I put a ring around that. Alright? State why a binary search is considered to be better than a linear search. 1 mark for saying you could have said fewer comparisons were made, or you could have said half the steps. You have half the number of steps to take because of divide and conquer. Alright? Right. Going to go on to question 6 here. This one looks difficult on the surface, but it's all about you looking at what has been assigned, looking at the arrows, looking what you only, as a programmer on trace tables, write down what has been assigned, okay? And I'll explain this in a minute. So I've got my list up here, all right? And the first item is, so I is currently set at 0, all right? The trace table is for the code. The first row has been completed for you. And what we're going to do is, if you look at it closely, we're looking at the value 21. Now watch. While found is false, well, found is already set to false. They've already done the first bits for us. And finished is false. Finished is false. I is set at 0. And down is already set at false. So that's why the first line is done for you. All right. Now it says, if array I, what's in array I to begin with?
0.
No, the value of I is 0. What's in it? 3. So if 3 is equal to 21, is it? No. So we don't do that on the first repetition. Okay. Is 3 greater than 21? Right. So discard that bit on the first iteration. Is 3 less than 21? Yes. Is down equal to true? No. Can't do that part of the if. So we know that I is I plus 4. What was the value of I? 0. So 0 plus 4 is? And because it's been set, there is a new value called 4. That's the first iteration done. Let's go back now. So now the value of I is 4. What's in 4? 0, 1, 2, 3, 4. So is 11 equal to 21? No, it's not. Skip that. Is 11 greater than 21? No. So we go to the else. Is 11 less than 21? Is down true? No. So therefore, that is not true. What is I plus 4? 8. Good. Right, we're going back up to our next iteration. What's the value in 8? 0, 1, 2, 3, 4, 5, 6, 7, 8. 34 now. So, is 34 equal to 21? No. Is 34 greater than 21? Right, so now, down is equal to true. Alright? True. Alright? And I is I minus 1. 7. We don't go to this else because we've done this. Right, we're going to iterate again. What's in 7? 0, 1, 2, 3, 4, 5, 6, 7. 18. Alright? But do we iterate again? You've missed a step here. Finished became true. So, alright. So we've done the I minus 1. Alright. But when you go back through again, that becomes true. Alright. So it's about taking it line by line. Alright. We've taken that off. Alright. But then the value was still false and finished was still false, so we checked it again. Does that make sense? Because that's why we had to do that. And I will just check the last questions before we finish.
Down is still true, right?
Yeah, it hasn't been changed.
It hasn't been changed. You only write it down if it changes, okay? This last one is a tricky one, and a lot of people mess up. I'm going to have to go through these quickly. It wanted phase 1. Not that it's split in 2 phases, alright? You need to explain what's happening. Basically, you find the midpoint of to do a merge sort, you find the midpoint, then you split it into sub-lists until you end up with individual lists with one item in it. That's what you've got to do. All right? So the list is divided into shorter lists. It is split at the middle item. You can say midpoint of the list and keep splitting into subsections. Each list is halved until you end up with lots of individual lists of one. To get this part B, where it's not in this mark scheme here, but I am telling you what they picked people up on the GCSE last year, is they're not acknowledging with a merge sort, when you bring it back together, that you compare the items. Look, when I bring a merge sort back together, I compare the items before they're joined back together. I know it's not on this mark scheme, but it is in some of the GCSEs, so just remember to write it down and acknowledge it, all right? So I know when I join 47 and 39 together, I compare them to see which is bigger. Then they're joined together. All right, and you can see that's happened here with the 21 and 59. That's already okay. Making sense? Now when I join the next lot together, those two lists are compared as well. The individual items are sorted. So you end up with another set of sub-lists that are sorted and merged together. Then, eventually, there's always a final mark to say the whole list is put back together in order. There's always a mark for that. Alright, so this is the last mark here. So I'll leave that up there. You will have your assessment next week with me. Use this to revise and take away some key points from this. When it comes to trace tables, always acknowledge where you have the arrow. That's when it goes into the grid. Alright? I'm going to stop recording and I will upload that video so you can watch it back. Alright?